Thank you, Adam, and welcome everybody. Thank you for attending our K-Compare Validate presentation this afternoon. We appreciate you spending the time to listen to us. Let's go ahead and get started. First of all, I want to talk about a few things what Kubotek 3D, or what we had in mind when we first started to develop K-Compare Validate. First of all, we knew it needed to be an independent check for translated CAD data, used primarily by the aerospace supply chain to validate translations. Excuse me. Next, we knew it needed to have an easy and fast workflow. And this sounds really cliche for most software vendors to say that our software is the easiest, but there's some really specific reasons why I'm saying this. And I'll show you that data in a few minutes. Next, we knew it needed to comply with aerospace quality standards, specifically standards like Boeing's D6-51991 standard. We needed to comply with many of the clauses there so that it could be acceptable product acceptance software used by the aerospace supply chain. We'll talk about that. And then finally, we knew that when we built K-Compare Validate, that it needed to have comprehensive validation application support. So we've been doing this for about 10 years now. Most of you know, we started with a tool called the Kubotek Validation Tool. And throughout those 10 years of experience, we've learned a lot about how our customers use and need to use a suite of validation software. There were a lot of things that we knew our customers used on a regular basis. So back in 2018, around April 2018, we sent out a survey to all of our Validate customers, and we asked a few questions. We wanted to do that because we're planning on building our new tool, K-Compare Validate, and we wanted to be able to use that data to be sure that the right tools were in the software when we built it. So the presentation you're going to see today kind of combines the data that we got from that survey, along with a demonstration of the new K-Compare Validate software as well. So a few facts about K-Compare Validate. First of all, it definitely will be the successor to the Kubotek Validation Tool. Right now, we offer both to our customer base, but that will end sometime next year, where we will only be offering K-Compare Validate, and no one will be end-lifing the Kubotek Validation Tool. Next, K-Compare Validate reads all major CAD formats. That's definitely a requirement for validation software. We want to make sure that you have as many formats as possible in your quiver when you're going to build your validation process. So we made sure that the new tool reads all major formats. This is an interesting point that wouldn't be obvious to you if you just pick up the software, but K-Compare Validate is built on our Kubotek's brand spanking new proprietary application authoring platform. So what does that mean? So over the past decade, or even a little longer, we have been developing our own application authoring platform. It's basically a math-based modeling kernel that we have developed completely at Kubotek. So we built K-Compare Validate on top of that brand new platform. So we own all of the technology in this new tool. There's a couple of benefits to that as well that are more user-centric. The first one is that with our new platform, since it's a new modern application built with modern technology, we've improved the speed for both file loading and comparison up to 400% in most cases. Another thing is it gave us a chance to go over the comparison algorithm and add more redundancy checks and make it more robust and more accurate. Really, really good benefits to you. And third, since we built a new application, we were able to completely redesign the user interface. A little bit of background, the Kubotek Validation Tool was a tool that we built on top of another software that we sell. So we actually took elements of that user interface to build the Kubotek validation tool. This new tool was built from the ground up with its own interface. So it is built precisely for doing validating translations, and you're going to see that it's a lot easier to use and a lot simpler to use. And there's some good reasons for that. So just to reiterate, what is the K-Compare Validate used for? Generally, when an aerospace manufacturer has an approved type design, they send it obviously downstream to their aerospace supplier. That aerospace supplier, when they use that data set for manufacturing, usually needs to read that into some type of manufacturing software in their manufacturing process. If that software is not the authoring software of that authority data set, in other words, if it's a CATIA V5 file and you're not opening it in CATIA V5, that's considered an import, and that's what we're trying to validate. Making sure that that read of the authority data set into whatever software you're using is accurate. What the process for validation says is, okay, read it into manufacturing software X, whatever you're using, and then save or export a derivative file. Take the derivative and the authority data set, compare them geometrically in the software like K-Compare Validate, and then write a certified quality document that you can use to verify with whoever is requiring you to do the validation that you've done it, and you have complete traceability back to all of the steps that you took to do that validation. So while it's a requirement, validation is also an industry best practice because it takes one error to get through, one translation error or one unintended change to the derivative data set that you're using for manufacture. It takes one to get through and have parts made. And this software will pay for itself many, many times over. It's a great check. Nobody wants to put bad parts on airplanes. So this is a good check, and it's an industry best practice standard to be doing this. So let's talk about the fast and easy workflow. I said I'd have some reasons for this. Well, what we did was when we polled our customers using that survey that I talked about, we asked the question of them, approximately how often do you validate translations using the validation tool? And this was the data that we got. And you'll notice that a good 85% of them do not do it on a daily basis. Some even monthly or quarterly. You know, a good almost 50% do it monthly or quarterly. This tells us that you're not picking up this software every day to use it, like some other softwares you might use. We also know that when you're doing when you're validating translations, it's an urgent task. You need to get it done. So this speaks to how easy the software needs to use. If you're picking up the software once every quarter or once every month, you don't want to have to relearn it. It better be easy enough to just use based on the workflow and what the workflow that the interface guides you through. So that's how we built the new tool. And if we go ahead and take a look at the new tool, I'll show you what the workflow looks like. So here's the new tool. Those of you that are familiar with the Kubotek validation tool can see that it's a lot different. There's basically 6 different tasks that you can go ahead and accomplish when you start. This is the home tab, obviously, so we can compare 2 files. That's most commonly what you would do. We can compare a folder or compare a list of files. Those are 2 batch validation modes that you can use. You can read a report, and this goes a little bit beyond reading a quality document that you've written. It also checks the certification of the document and allows you to rerun a validation that you did in an audit situation. If an auditor ever said, you know, hey, I want you to show me what you did for that validation, you could completely rerun it using this tool and the quality document, and I'll show you that in a minute. This is just a customized application. There's just some global options for the software, really simple. I'll open that up so you can see it. Things like colors, units, those types of things. Really simple. Dialog box, and then a self-test button. And the self-test is basically a batch validation on a known collection of data sets. And that's a requirement for D6519991 is that you're able to check the installation of product acceptance software, which Kcompare Validate is. So you can check it through that self-test. So let's go through the workflow. If you want to compare two files, it's pretty easy. You click Compare Files. The dialog box asks you to define your authority data. And let me go find mine. Hang on 1 second. So I'm going to pick this authority step file. And then my derivative is a parasolid file in this case. You can see that the two files quickly open. If I rotate one, they're automatically synced together. You can change the shading. You can change the major views pretty easily from the interface. You can do a zoom window or a zoom fit. Let's go ahead and put these in the isometric view and do a zoom fit. Okay? So you can see, if you have familiarity with Kubotek validation tools, there are far fewer commands. Only the commands that you need are here in the interface. So the next thing you do is go ahead and set up your compare options. And we've greatly simplified these as well. So you basically pick the type of geometry that you want to compare, apply a tolerance, and the Boeing standard says somewhere in the neighborhood of 1/10 is the smallest manufacturing tolerance. We'll stick with 1,000th of an inch here, and then compare direction. That's how you set up the options. And then when you go to compare the files, you literally click compare, and this is a summary of your results. So that's what a validation looks like now. Much, much simpler and much easier workflow. From here, you can go ahead and create a report. This ends up being your quality document. And I'll save it as test. And you can see that the report opens up again on its own tab. If I come back to the tab where I compared these, let's take a look at that read report button. I'll close both of these down. Let me use the read report button. So if I go to read report, let me grab that test report that I just wrote. You can see that it opens up the quality document. And again, this is all about traceability, right? So it's got the traceability information for the build of the software, for the authority and derivative data set, for the options that you use to compare the two files, and then it's got the ID numbers of every entity in each file that was compared. And let me show you how that works also. So just keep in mind the number 9330. That's an ID number for a specific entity in the derivative data set, okay? What you can do from this, now, again, in an audit situation, let's say we were opening this document 3 months after we had done this validation. You can always go back now from this document and click Open Part Files, open them, and then literally just compare those again. So you can completely recreate that validation. And remember those IDs that were in the report. If I go 9330 now, I can find that ID. It basically zooms to that entity. And it's this blend right here. This face 9330 in the derivative data set. And it also shows its pair there in the authority data set. It also finds it in the list over here. So derivative data set face 9330 was paired with derivative data set, authority data set face 1366. So that's how you get traceability for your comparisons. Let's jump back over to the PowerPoint and talk about a few other things. Next on the list is compliance with the aerospace quality standards. And we brought out a few of the points here so you can take a look at them and understand what we're talking about. First of all, we're basically talking about Boeing D65199. There are a couple of clauses in this that are important. First is the product acceptance software. I talked about that a little bit already. And basically at the bottom here, it's saying that supplier product acceptance software verification shall be performed using calibrated standards, known physical artifacts, or embedded software testing. That's basically what that self-test is. It's a test of known physical artifacts, and it's embedded in the software. So When you install the software, you can click self-test, and it generates, as long as all those files pass, you know that that installation is good. And that was meant to comply with this part of the standard. The other part of the standard that's important, obviously, is that the part about validating translations. So basically, if you're reading the native file into its own software, no validation is required. However, if you're reading any other file format into a piece of software other than its native, then you need to do a validation, and it's strongly recommended as an industry best practice. You can see that down at the bottom, and I kind of mentioned that earlier. So those are the two parts of the standard that are really important. So again, that self-test becomes important. If we want to take a look at that, we could go over into the software. You click self-test, and there's basically a bunch of a whole set of known digital, what we call digital artifacts. It's basically a solid model that has one of every type of surface, or most types of surfaces, that we can then translate through a number of different softwares, create derivatives, and then make sure that they all pass. So we do that on a regular basis. And what you're seeing here is the result of the comparison of those digital artifacts, and as long as they all pass, you know that the software is installed properly and working properly. So that's what the self-test is all about. The next is the certified quality report, and you'll remember that when I read that quality document, it said the report is certified. Let's go back and show that again. If I read the report that I wrote earlier, you'll see up here at the top, the report is certified. Well, if I went in and this was tampered with, what would happen is that would say report is not certified, and you also wouldn't be able to rerun the validation like we did earlier. So that's what that's about, and that's part of the quality system compliance as well. The next thing we want to talk about is, okay, what are all the tools in the software that you can use for doing different types of validation? We'd like to say that it's always just load one file, load the other, compare them, done. But we know that there are some special case validations that are out there that are important to our customers. And again, we use some of our data from that survey to make sure that we included all these types of validation. So the first one that's important to talk about, and this happens all the time, is limited scope validation. We saw this across. I don't even have a slide for the survey data for this, as a matter of fact, because we know every customer has to deal with it. So that's what happens when the the authority data set has more data in it than the derivative data set. Probably pretty common, or we know it's pretty common. Take a CATIA v5 file. If you get that and you need to generate a derivative from that, you're likely only manufacturing, to the part in the v5 file. Within that file, there might be extra construction geometry. There might be reference geometry that you brought in, maybe a part of an assembly where the part you're designing actually has to be built in context with another part. There's a lot of geometry that could be in the CAD part, and we know that when you generate a derivative for downstream use, you're probably just going to take the part that you're manufacturing to. That automatically sets up a mismatch in the amount of geometry in the two files. So what happens, a literal translation of that would be that there's more geometry in one than the other, fail, it doesn't pass. So what we need to do is give you a mechanism so that you can ignore the geometry that you don't care about or that you don't generate and put in your derivative data set, but it's traceable. The fact that you ignored it is traceable, again, for obvious reasons. If we do that, then we can say, okay, this passes because we're only comparing the derivative to the geometry that it represents it in the authority data set. Let's take a look at that. So again, I'll pop back over into K-compare validate. Let's close our quality document, and I'll compare two different files. So I'm going to take the same authority data set, and I'm going to take a different derivative. So in this case, if we just go ahead and compare these two files, there are a lot of differences in these two files. namely these two paths that exist in the authority and not in the derivative. Okay, so let's say we wanted to ignore those two paths. What could we do? In K-compare validate, you can expand the part tree from the left side of each window and expand the part to find out what data is in the file. So in our authority data set, we've got 3 solids. In our derivative data set, we've got two sheet bodies. Okay, it doesn't look to me like there's more than one part in the derivative, but in the authority, it's clear that there are extra solids that don't exist in the derivative. What we can do is in K-compare validate, we can right-click on those that extra geometry and actually hide it. This is a fundamental difference between K-compare validate and Kubotek validation tool, is that if we go in and hide geometry in K-compare validate, it's excluded from the comparison. The other difference is that when you read geometry into K-compare validate, we're reading the entire contents of the file. We don't allow you to limit what you're reading. That way, we read everything, and then we hide what we don't need, and then the validation is completely traceable. Okay, so that's a fundamental difference. Now, with that geometry hidden, if we go ahead and execute the comparison, you'll see that there's just one difference. And if I zoom to that, it actually is a space in the authority data set that doesn't exist in the derivative data set. So that's how we deal with a mismatch in the amount of geometry. Another thing is, let's say, you've got a hole routine that generates these holes, so you're not really machining to the surfaces of this hole, you just want the center point off the model. Well, then the fact that this space didn't translate is irrelevant to your manufacturing. So you can always right-click on a difference and disposition it and say, not applicable for manufacturing, let's say, whatever you want to write there. The fact is I can disposition that, and now it's no longer an error. It still shows difference, but all my errors are dispositioned. So I can say that, yes, I had an error, but it's not consequential to me manufacturing the part. I've dispositioned it. So now I can write my quality document, and it will indicate that that disposition has been made. And again, that's completely traceable. So here I'm showing you the quality document. There was, in fact, an error at 1/1000th of an inch, but that error was dispositioned for a given reason. So that's how that works. And that's how we would validate 2 models with different amounts of data. So we limit the scope of the validation. Jumping back over, the next application scenario that we know a lot of customers have is when you have to read your authority data set into some CMM or inspection softwares that are out there. PC-DEMIS comes to mind specifically, where when you read the authority data set into PC-DEMIS, it's got limited export capability and can't save a solid model. So if your authority data or your authority design is a solid and your inspection data can't, or your software can't save a solid, what do I do? How do I validate that read into that software? Well, the answer is, in most cases, that instead of saving a solid model, you use the inspection software to put point nominals on the solid and then save the point nominals. Most softwares can save point nominals to IGES. So we do that. It's a B answer, but it's an acceptable answer to Boeing. We've had this functionality in the software for 10 years, so we know that it's an acceptable way to validate models, as long as it's documented that you're doing it this way. And in that case, we can compare points back to the solid and validate the solid that way, or validate the authority data set that way. Let me show you what that looks like. Or actually, sorry, we did do survey data on this one, and at least 65% of our customers do this at some point. So we know it's an important tool to our customers. That's why we put it back in K-compare validate and made sure that it was robust and worked well. So let me show you how that works in K-compare validate. If I go ahead and compare 2 files, again, this case, I'll take the same authority data set, But now I've got my derivative that is actually a set of points. One thing I get a chance to show you here is that there's an automatic overlay view in K-compare validate. So at any time you can just overlay the two models and vary their transparency so you can get an idea of where the points are on the model. Okay, I can jump in and out of overlay view whenever I want. That's the difference from K-compare validate. Sorry, from Kubotek validation tool. That was a completely separate mode. And then what you need to do to compare these two files is go into your options. I don't really care about comparing faces and surfaces to each other. I want to compare points to faces and surfaces. You'll notice that it automatically goes into derivative to authority mode for the compare direction. In other words, derivative points to authority surfaces. I click OK or compare, and I get my results. If I show them, you're going to see that all of the error points are along this bolt hole circle, if you will. If I overlay them, you're going to see that they're basically the hole centers. So they weren't really meant to be validation data anyways. So again, in this case, I can say, I can shift select all of these and disposition them and say, reference points not used for validation. So I'm dispositioning those differences. Again, they become a disposition, and that's how I complete that validation. But that shows you an example of how we do points back to the authority BREP solid or surface model. Go back to my PowerPoint, and let's talk about the next case scenario, or the next validation scenario. We know that some of our customers, when they're generating a derivative, for whatever reason, the derivative ends up being in a different orientation than the authority data set. Well, literally compared, that's a failure. So what we need to do in order to make this work is apply what's called a derivative adjustment. In other words, reorient the derivative so that it's in the same orientation as the authority data set. So if we reorient the derivative, then we can compare these, and it's a pass. The big thing here is that we have to make sure that that derivative reorientation or derivative adjustment is traceable and mentioned in the quality document, so that you know that that's what happened when this validation took place. So how does that work? Or how many people use that? Excuse me. We know that from our polled customers, 85% at least do it at some point, and a good 70% do it sometimes or even usually. So we know it's an important tool to our customers. So we put it in, and this is one that we actually improved quite a bit with some advancements in technology and some modernization of the tool, and I'll show you that. So if you look at validating points or parts in different orientations, let's go ahead and compare files, grab the authority data set, and grab a derivative data set that's been reoriented. First of all, the reorientation is subtle. But again, with the new overlay tool, it's pretty easy to overlay the two models, and you can see really quickly. This might be something you do as a best practice, just overlay the models and take a look before you validate them. These are definitely in different orientations. Okay, so if we come back into the compare space here, there's a tool up here called Transform. In Kubotek validation tool, it was called Reorient Copy. And basically, there's an automatic and a manual transform. They both apply a transform to the derivative model to reorient it in the same orientation as the authority data set. Manual is a wizard that makes you put 3 points on the authority data set, excuse me, and then 3 points, the same 3 points on the derivative data set, and the reorientation takes place. Automatically is what we use most often. And that automatically is based on the fact that with K-compare validate, we now scan the model when it's red because of the advancements in not only the authoring software platform that we're using, but also the speed improvements that result from that. We're able to scan the models when they're read, so we have information about the models before we even start to compare. That's why it's a lot faster also. So we know that basically all of the face geometry on the model, and we can use that to actually reorient the two models. So if I click automatically, you're going to see that this thing reorients automatically. I can accept that orientation. And if I go into overlay, there's no visual reorientation of the two models at this point. Looks like it did a good job. The real test is to go ahead and reset my options so that I'm comparing faces in both directions, and then execute the comparison. And you can see there are some differences here, but those differences are all due to that extra geometry that we talked about earlier. If I wanted to make sure that this passed, I could just go ahead and open the tree for the authority data set. Again, hide those two solids that we know are extra geometry, and then go ahead and hit compare again, and now they're the same. The other thing that you notice is that there is now a derivative adjustment here that lists in the quality document, it would list the transform that was made on the derivative file. So again, it's all traceable. The last thing I wanted to talk about was batch validation. It's another tool that we've made sure was in K-Compare Validate. We know that there are customers out there that do batch validations, although it's much less widely used, a much less widely used tool than some of the other ones I've mentioned here. Batch validation is important to many of our customers, and it basically gives you the ability to take either a list, which is a text list that has a very specific format and allows you to define a batch validation, or it allows you to place all your authority data sets in one directory and all your derivative data sets in another directory, and then set up a batch based on two directories. And that's the type of batch validation that I'm going to show you. So let's pop back over into K-Compare Validate, and I'm going to use the Compare Folders batch validation. And I've got an authority folder, and again, a derivative folder. You're going to see that my derivatives are all step models. My authority models are all cat parts. The tool is smart enough to know that if the file name, everything ahead of the file extension is the same for the two files, it will pair up those files for comparison. If it's not, then you have tools that you can manually use to do it. So in my case, I'm going to align this file, which has no pair, to this file. Again, I'll align this file to this file, and I'm just setting up the pairings that were not automatically realized by the tool. And again, that's because of the differences in the file names. So now I've paired up or matched all of my files. I have compare options for my batch here. And again, I'm just doing faces in both directions. And then I hit the play button, and it's going to go through and do this batch validation. And you can see by the readout here that more than one validation takes place at once. That's because this tool is completely a multi-threaded tool. So it can take advantage of multiple threads. As long as your hardware provides those, multi-processors, we can really take advantage of that with the new software. You're seeing here we're processing about 15 or so pairs of data. Give it one more minute. when the batch is done, you get a batch summary. This can be printed out. This is not a quality document. It's just a summary of the various comparisons that you just did, each with its own pass or fail marking on it. So down here you can see that of the 15 that we did, 3 had errors, 12 data sets passed. If I close the summary, and again I go to my my batch comparison here, I can take any one of these and and open them and show you that and execute that comparison directly from this interface. So it's a really nice tool. Again, if I double click on that data set, I can open it up and it'll show you the results here. So that's how we can look at these individually. Obviously, the best ones to look at would be the ones that are in error. Let's load up these data sets. And it would show again, the errors in the 2 data sets. So that's a really brief introduction to K-compare validate. Again, we built it so that it would be an independent check for translated CAD data. It had a fast, easy workflow, which is for the reasons I showed you. Compliance with aerospace quality standards is really important because of the way this is used. And then all of those tools that our customers need on a regular basis, we made sure to make them as robust as possible and include them in this new release of the software. I'd be happy to go ahead and answer any questions. And I just wanted to, again, thank you for spending the time with us today. We know your time is valuable and we really appreciate it.